अनम्यूट करने को बोल। हाँ फुल स्क्रीन half only visible.
It's not visible. It is so small that thing. Said
ये तो लाइव शुरू हो गया. नो इश्यूज. यू शुड स्टार्ट sitting here and end when it is ending. Just call David first.
Can we can no, what I'm saying all this is try to imagine a situation that where I will not be doing anything. A computer will simply do the entire things, or a mobile will simply do the entire things. So this is possible. What is the technology? The technology is, and then if you want to invoke dynamism in that technology, you have to invoke the artificial intelligence or AI ML, which will ultimately make it adaptive. As the situation changes, it will also change. So that is the reason that whenever if I take a very simple example of additive manufacturing, what is that? It is slightly, if you say that is a microscopic droplets which will be ultimately deposited layer by layer, and ultimately it will be forming a compound, which is a design compound, and in accordance with that design has got a background of getting it designed by some kind of simulation and modeling and simulation. So there is something. And then after that, if you want to make the modeling and simulation process dynamic, you have to go, or adaptive, you have to know what is that kind of artificial intelligence you have to invoke there. So this is one particular point. The second issue is that, now what are the other issues? What are the other challenges in this additive manufacturing? I am depositing there by there. It's very easy to say that you are depositing, you are controlling it, you are digitizing it, very easy to say. But after digitization, after preparing that component, whether it will be useful or not, that's a final test of it. So that is the reason why you must know the underlying science. You must know the underlying science. So these are the challenges which I'll be trying to highlight a few challenges. Now, the creative designs, wherever you will be doing with some intelligent materials, because people are not talking about classical materials you cannot really replace altogether. But within the domain of classical materials, how can you functionalize it, or how can you tailor it to make the same material multifunctional? So this is one important. We know all that the concrete is a building material, but how can you make a concrete smart concrete? Whether the concrete will be embedded with sensors. The sensors means that the outside sensing agencies, you will be simply embedding that as you are doing for the wearing, the constant wearing. It's not like that. We are not interested in that. Basically, that particular thing will be able to sense. So that is what is a smart concrete. In my definition, that's the thing. So when the multifunctionality has to be invoked, that is to be there. Now, if you come to the medical sector, the wearable electronic devices, the electronic gadgets, if they are to remain wearable, then you can do that to the polymers. But who will ultimately drive the process? You have to have the battery. So you must be dispensing with the battery also. So you can be using some kind of material which will be able to power the electronic circuit. Why, if your band, the band of that electronic device, which is the band which is used to wear, if that can supply the power to that electronic circuit. So this is also the people are thinking about that. So this is called the thermoelectric material. So this thermoelectric material should take the heat, body heat, which is always there, 37 degrees Celsius, and there it will be producing a new amount of energy, electrical energy, and then that will be powering the circuit. So you don't need any battery. So that is how the theory will be. And then you can also embed within that the diagnostic devices and then also the treatment. So that's what is the research. So everywhere you see, if you find that the two different processes are having same elements, but the manifestation is different, the genetic makeup is different, so they are the person-specific drug administration is a technology we are talking about in different countries. Now, how do you do that? Unless you know that X and Y, they require this thing. So that is the reason why the typical database is there, and then you have to apply your AI/ML, and then you will be finding out if this is the gene mapping or the prehistory, you will be mapping that thing, and then you will be automatically diagnose that this is what is required for this technology. So this is the technology which is being used or which is being used. So that is why where the digitization or we really mean that that is a digital manufacturing. And then whenever we talk about these things, we must say that additive manufactured components should be such that it can change the color. So with that kind of smart materials, you have to do that. And you can also produce, as I said, that without any cables or circuits, you should be able to, only with the external stimulus, that is by sound or by heat, it will be doing. So this is what we really mean. So, I'll be talking, why do I say that? I will be hinting you whenever you will be coming to real life additive manufacturing. You may think, you are basically Professor Genius is an expert in WAM. So WAM is a technique where you can very easily refine that technique down to additive manufacture to any scale. So this is what is important of WAM. That is, there are certain problems also. Want to be used for additive manufacture, specifically for the strategic sectors, then you have to get the materials as a form of electrodes. So quite obviously that the flux will be there and automobile, or many things will be coming to picture. So the fluxless electrode can be there. So these are the challenges. So you have to talk about the challenges in additive manufacturing, and then here you see that the space, the military applications, the space applications, the armor applications, or even for the VIPs, the armor applications are there. Why AIM is there? Because AIM is basically required to make it as perfect as possible. So what AIM can't do is that AIM can't really give you it can give you near thing. But we are not happy with that these days. We are going for a so precision design such that it will have to have that kind of design confirmation. So this is what is important. And then, as I said, that the complex shapes, CUDA shape means I really mean 100% fitment of shapes and having the exact desired property aspects. So these are the things for which if I want to do that, every time Professor Asara hinted that the new materials they are every time the new materials is. So therefore, material means that new material, new technology means that the higher energy consumption. So every time we have to find out what is how can you minimize the energy consumption? Because that is another pressure from another technological arena. So that is the reason why this kind of optimization of everything, that for which you have to bring once again the digital technology. So this is one. Then forget about that, these are the things, the complexity of modern warfare. So this is another important thing, that lightweight armor solutions. Whenever you talk about the lightweight armor, what do you mean by the lightweight? What is the light, degree of lightness? So degree of light. So that is another important question. So who will answer that? So we cannot search all these materials, we cannot prepare, we cannot test. What we have to do is that, again we have to use such kind of artificial intelligence on the basis of existing database and trying to derive a design rationale by virtue of which you will be actually design a material. And once you actually design a material and then you try to go for that. Then once or twice you can go for the experimentation and you can see whether the actual design is up to the mark for your use or not. So this is how the entire thought process has to be modified. Unless you modify the thought process, if you try to be confined with a mindset locked within a domain only which you prefer to dwell, then you are not going to be fitting into the upcoming days when the technology will be changing. The half-lives of technology has now been reduced to 1 year. It will be reduced to 6 months, it will be reduced to 1 month, and then it will be reduced to 15 days or even 2 days. So you will be facing, the young generation will be facing some challenges like that. So therefore, if you do not have that kind of scientific background, you will be misfitting that technological scenario. Now, so you all know, many of you are mechanical engineers having good exposure for the this additive manufacturing. You know that it has got the ability to fabricate complex systems. But what it does not have is that it cannot ensure the many things which are being coming in. So you can prototype by AI. But prototyping means that whether it's a successful proposition or not, there has to be certain kind of test for you. So naturally, you have to allow what it does do is that you can really get a similitude by the application of similitude and modeling concept. You can produce a model and you can see how does it function. So once you see that its functionality is up to the mark, you can create a real life object and then you can put it in use. But however, whenever you do it, you can do it also if you have got sufficient intelligence in the entire process. You can embed sufficient intelligence in the process. The online design, suppose a soldier is in the front, the war front, then he wants to get something. And then additive manufacturing can create components for him. And then the only thing is that he has to know this. That is also a done. The human resource skill is also a very important aspect. That's the challenge. Now, custom design, not only body art, any custom design, suppose it is required for X, wrist size is different. So Y, wrist size is something different. So therefore, in accordance with X and Y, I have to produce that. If you go for any shoe or shirt shop, then you will be seeing that the number, they are talking about numbers, 31, 32. So these are all discrete numbers. So the entire world is discretized world, and the entire science is discretized. So once that is there, so naturally what is that? But the discretization has got some limit. So for 282% or 83%, if I try to rationalize the discretization, then individually someone will have to have something undersized, someone will have to something oversized. Maybe they are managing, but they are not really fitting for that individual. So now we are talking about that. We are saying that let us reduce the margin of discretization. Let us reduce the distance, barrier of discretization. So as if it is a quasi-continuous process. So once because you cannot make it a quasi-continuous because that concept is no longer there. So the quantum physics has already eliminated that. So therefore, we have to believe in that quantization. But this quantization, whenever you go for a very quasi-continuous area, then naturally you will be satisfying more and more. So that kind of perfection we are talking. So this is not possible for the conventional manufacturing technique. So this is possible for additive manufacturing, the tailored component manufacturing.
Yes, ma'am. Okay.
So these are, I've already told you. Professor Asana was talking about the composites. Now what kind of composite will be required for additive manufacturing? What kind of additive manufacturing will you do? Who has told you the composite means that you are always thinking that whatever you are producing, that is a very uniform structure. But it is not a guarantee. Who has told you that it is like that? There cannot be any kind of perfection to that. So therefore you must know where you stand. Whenever you are going to do that, then you will be finding that this is another challenge. That whenever you go for the additive manufacturing of any kind of any composite material, then you have to know what is that technique. So you have some techniques at your disposal. It's not that. The monitoring of that technique is important, much more important than anything else. Whether you are able to change the parameters of that technique at each point of time when the situation demands it. So this is very important, and that is given by the application of the digital technology. So you have to understand that nobody will tell you that is again a mechanical aspect that you apply AI/ML. That is a layman's statement. What you have to do is that you have to understand. You are all very intelligent creatures, so you have to understand that the digitization is the theme, and how will you apply that has to be decided by your own understanding of the situation. Your understanding has to be defined. So that is the most important thing. So just like a very blind person, don't say that I'm using AI/ML. But you have to find that AI/ML has to be adapted. People are talking about the manless vehicle. It's running. Google has already put it there on streets. The US is running. Now the thing is that they will be the ultimate cabs, but they are also under track. So they are not given totally, the government has not yet accepted to be on regular use. But the thing is that the situation which is anticipated, if it is a stagnant predictive activity, so the situation what is anticipated, all of a sudden it can change. You are coming from your house to MRI, and you know very well that your Google Maps will show you that this is blue, this is red, and this is something like that. But what Google does not know is that right at a particular instant of time, some mob can be collected and they can create chaos. So you cannot ignore these accidentals. You must be knowing a few minutes before that is happening. So if you can have that kind of adaptive technology, that means whenever something is there, then you change the route. So this kind of technique, adaptive, say I'm just talking about the neural network, where the adaptive control system of the vehicles, planes. The planes, whenever the planes are there, then they are getting the front planes and the back planes, they are where exactly the plane of flight, where they are the distance, vertical distance, the trajectory, everything is known, the nearby flights to one particular pilots. Now, what is there? That something may happen, that some casualty may be there. So therefore, whenever that is here, then what is that casualty? Whether you can do that kind of thing. The control system, suppose is a man-less. If the man-less, then naturally that kind of adaptive control has to be there. So what is that adaptive control? Again, that is typically neural network. It was initially started with neural network. Now we are talking about the deep learning technique, which is nothing more than a neural network, a complicated neural network system. So that is what is important. So who has told you that it has to be done? You are told it. That is what I am saying, that generalized statement has got no meaning in our case. So whenever I am trying to put one aim in operation for the strategic use, then everything will become strategic. A few days later, your car is a strategic item because your safety is of fundamental importance. Your safety is a fundamental importance. Of course, we the automobile guys, our automobile engineers, automobile manufacturers, they are thinking of the passive safety. They are thinking of the design of the car in such a manner so the driver will be safe. And the passengers at the back will also be safe. But to make it guaranteed at any particular point, because it does not know, you can't design that. You will be having a design limitation that if a truck comes here and head-to-head collision is there, the truck load is there, its momentum is there, its force is there. Now, there can be something which is of more, with a higher momentum and with higher energy can collide. So if it is there, it should be ready. How does it go? It should go after at least a few seconds earlier. So once it goes, it will change its strategy. It will change its course, it will change its route, it will change the lane, so anything. What is happening nowadays, you are also running the automatic cars, you are simply doing it. That whenever the distance between any two cars are within the limit, then the sound is there, and then you either control your accelerator. So that's what you are doing nowadays. So you just extend it to a very higher complication, and then you extend it to an AMD. So that is what is there. That's why I have taken everything in the. So these are the known things, that this titanium, aluminium, vanadium alloy, aluminium, silicon, magnesium alloys, and the margin steel. Because there is a space application is there, so quite obviously the very complicated items are there. The people are already standardized. They claim that they are standardized. But this standardization is again something. Tomorrow you will be coming out with a material which I do not know. It is much better than margin steel. Then what will be its aim technique? What will be its aim technique? I must knowing it. And then maybe the material is such that you cannot make it such kind of your so-called warm or so-called SLM technique. You may not be able to do that. Then what is it? So that also you have to know. SLM has also got something here. Because it's a microscopic particle at its core. Now, whenever you are getting a microscopic particle, you are getting. So there are problems which confronts the surface finish of the product and the insurance of the property. Layer by layer coherence is a very, very important thing. The mechanical engineers as well as the people dealing with the strength of materials, they must be knowing that this kind of thing, if the anisotropy is there, then there will be a tremendous difficulty in use. So we use this, but the laser we use. So optical manufacturing we can also use. So I have also listed some of the techniques which you all know. I am not going to detail those techniques because you all know that where exactly these applications are. I am simply trying to highlight the challenges. If it is not really doable for my product or for my use, then what is to be done? So that is the challenge. Why the challenges are inherent? The challenges are inherent because whenever one layer is solidified, other layer is solidified, then the solidification rate is different because when the second layer or overlying layer is there, then already the heat transfer is going through the material which is already solidified. This thermal conductivity is a function of temperature. So therefore thermal conductivity is changing, and the solidification time is changing. If that is there, then that creates the nano voids, and we may be ignoring to the ordinary optical microscope. But for a particular use where I want a very, very high precision, high safety, I will fail it. I will fail it because my design might be correct, but material processing has not been. My additive manufacturing, most precision manufacturing I have done, but again, it is not 100% sure that you have made a fine thing. Very good. You may say it's a very big talk, saying that I have gone for the 3D. But what is the science in that? How do you ensure that your properties point to point of that component is same? The point to point, it has to be same because if the three-dimensional object is there, if the three-dimensional object is there for the fitment for any particular purpose, is that if there is a differential property, even whatever is the mathematical point to point, then that will be the center of stress concentration. Whatever is the stress, the thermal stress, mechanical stress, electrical stress, and then that will start the failure of the material, premature failure of the material. So therefore, the matter appears to be simple, but it is really one important thing to consider. Now, mechanical metamaterials. The metamaterials, the design of metamaterials which is having a negative refractive index. It has got a tremendous connotation for the defense. And you'll be able to see the people who will not see. Once you make use of the metamaterials as you wrap out, then you will not be seen by your enemy, whereas you can see. So this is the kind of thing, so what kind of that metamaterial which will be mechanically wearable, which will be flexible, and which will be light. You cannot take 5 kgs of apron. You have to take few grams of apron. Whether also that will serve your purpose. So these are the things where the exceptional mechanical properties and the transformative features are to be embedded, and that can be embedded by this particular technique, provided we have the sufficient knowledge of the materials, of the processes, the perfection of the processes. So these are the things. Another important thing is the feedback in their iteration, several iterations. Suppose something we have a few portions, and then immediately it is being monitored. Its quality is being monitored. So all things, whatever issues are important for you. And then if you go give the feedback to the manufacturing setup, okay, you are not moving right. So you have to change this. So this is what you have to do. Now it is nothing immediately, you cannot get a tailor-made AIML technique. The AIML paradigm is there, the thought process is there, and you can manipulate it. So digitization may appear a very catchy word, but I will say that as a scientist, as a technologist, you should have the correct meaning embedded in your mind. So this is important, and I say that it is possible. It is possible to do by the people who think. So here, there was the importance of Professor Asthana's every point. We have to take it by our heart, and then we have to downsize it to the additive manufacturing, and then we have to see the practicality of applications and the difficulties, what can be there. So these are the techniques which we still now all these techniques, SLM and other part of it, future techniques, we are not able to capitalize. They can't have any solution for that. But the thing is that, okay, that is all right. The microscopic particle is there. We are not very satisfied because the original property is determined by atoms. Not by atoms, basically by the electron, extranuclear electron. I am not coming down to electron. I simply let us be confined at the atomic level. But whenever you are going for any additive manufacturing, SLM technique or not, so basically you are creating some powders which is microscopic size, the micron level body. We don't want that. We want some nanoparticles which will be of the order of few angstroms. Say the atomic diameter is 10 to the 4 angstrom, 4 angstrom or 5 angstrom. So naturally around how much it comes? 0.4 nanometer. So, something like that it comes. You can see how does it come. Now, if that is there, then you will see the sub-nano we are talking. So how do we do it? So that is what is there. I'm coming to that. So this kind of thing is very important and collaborative initiatives. It is not required that you will be a specialist in any technique, computational or technique or artificial intelligence or everything. Your thought process is important. You should share, you should collaborate, and you should get your results. And that is how you can advance the technologies. So this is the other thing. So whenever you go for the widespread application of aid in the strategic sector, then the different challenges are there. One challenge is everywhere. That's defense. I have taken the example of space also. But there is no standard. It's okay. For your state or for any other component or any other place, you always say, I want to have the base case, this specific that. So there is no specification of precision for the strategies. Either space or defense, they are normal, conventionally produced or manufactured items, whatever specifications we use, we are using the same thing for that. Why not? It will have a manufacturing is one way we are training, we want a very, very high capital material or problem. But again, I say, when I'm measuring it in terms of a very conventional one, whom I'm going to replace, then I'm suffering from self-contradiction. So there has to be something which will be more challenging for the aim material, that their specifications will be more challenging, and that will be exclusively true for aim component, which is not possible for the conventional manufacturing. That is the essence of then it means that real life, that proves the essence of additive manufacturing. That's not there. So it's a challenge. Someone has to do that. That is a challenge of the government to do the regulations. They can very well, they can make a regulations, the regulatory body, that this kind of, say, 10 nanometer, 10 micron particles cannot be released from any industry. So the Central Pollution Control Board says that. So that is a stipulation. But what is that technology that can ultimately do that? And why 10 micron? The first code, my good says that story. Doctor does not say it. Doctor says, what is the aperture of the lungs? So that is the limit. That should be the limit. So inhaling those things, that should be the limit. So you have to think that it is vital. Additive manufactured components should keep that. So have we thought of that? So this is the challenge. We have to take of that, and then we can do it. As I said, that the dimensional control is a misnomer in case of additive manufacturing. You were talking, someone was talking about many things they were responding to Professor Astana's thing. Now the solidification and all this. The solidification of front and a macroscopic solid, this solidification you are able to predict. You are predicting, so that's why you are responding. But I am interested in the solidification, the difference in solidification rate of some droplets or some micron level droplets. So therefore, my understanding level has to be slightly different from the conventional one. That's why my essence is there. So here you have to invoke the knowledge pool where the question of bringing the data and then processing it, and very fast you have to process the data and immediately you have to transfer it to the production system. So this kind of thing is still missing, and that is the challenge. So the quality challenge is a major important thing for any. So still now, whatever researches you are doing, you are simply confident that, okay, my component is very good, you are getting your PhD, you are publishing the papers. But if you see that what is the, you will be showing me that there is no point. So just see how good a component is mine. But have you seen it in a transmission refractor microscope where there is a nanopulse or not? The material, the crack, the interatomic distance or a vacancy in a crystalline material is a crack. But that can grow under certain circumstances. That will normally not grow, but that may. People, scientists of fracture mechanics, they are thinking of that. That if the short crack grows, till that time, what is that called? Paris law. Paris law was here that it was talking about a critical, entire fracture mechanics was based on a critical separate cracks. Now, what is that? If I have a very subcritical crack, you mean to say that the component is not going to fail ever in its life? It will fail. Then that means the short crack growth also comes to the picture of critical crack length. So who is responsible for that? So we have to keep. So therefore, we must have to make the crack shorter and shorter to your additive manufacturing, such that it is prolonged, delayed, and in my lifetime it does not crack. So if I can do that, that is the challenge of technology. That is the challenge of additive manufacturing technology. This is important. These are all things you know, that these are the common challenges in your, what is that called? The manufacturing technology. The same thing is stated here. And the technical imperative, I have already told you in my page. This is important. Now, digital printing of colloidal particles. So we are now thinking of colloidal particles. So the same additive manufacturing of 3D printing will be doing with the colloidal. Try to understand what is the size of the colloidal. So these colloidal particles we have to create and say we have to make use of that. So therefore our entire thought process has to be changed from the microscopic to sub-microscopic. So how do we change that thing? Because we are thinking about the colloidal nanoparticles for manufacture. So this kind of nanomaterial is precisely tailored by the size of the nanoparticles. And these nanoparticles are so small that it does not really get comparable with the particles which we have been talking about in a special technique and so-called classical. I will be now saying that the conventional additive manufacturing. This is what I want to say. The conventional additive manufacturing. So we are not conventional, we want to go far behind. So this is a typical advancement of your additive manufacturing. I want to go for atom by atom position. So our consideration from the microscope of particles to the interaction of atoms, which I think finally decides the property. We are now coming down to that level of manufacturing. So once we can do that, so that is why the colloidal nanoparticles are used, and that again, the conventional technique you can use particles. So therefore, these interactions are down to the atomic level, atomic scale. And then, if we can mimic the computer-aided design model, the same computer-aided design model, and then the external field of the sample state can change, we can deprogram, then we can manipulate the particles digitally. So this is how we can invoke the entire thing. So therefore, digital manufacturing is based on digital design and control of manufacturing process. You are promising that. So this is what we have to do, but we cannot do it if it is a microscope. We can do it if it is an atomistic, because atomistic modeling is there, and then there are Monte Carlo simulation technique is there. There is your DFT, the density function theory is there. So these are the laid down theory, the proven theory. So there is an option for them to be used here instead of publishing the theoretical paper. Here you can invoke this kind of digital design and control of manufacturing process through digital technique. So every conventional manufacturing technique can be displaced. So the conventional means that I now am including the conventional additive manufacturing. You may be saying that this is advanced technique. I am saying that this is conventional additive. It is not yet able to come out with this. So these are the optical nanoprinting. The optical nanoprinting, why? Because we have used the optical things. So laser is an optics. So laser optics, naturally, we are using on the digital control of a laser beam, and then optical fabrication, organization of atoms, and assembly of nanoparticles. So we can do that. So this is a possibility, and extremely. This is the real sense digital manufacturing. So once you do that, you see that what I have written there. That you have to incorporate the nanomaterials of different sizes and stages. These are all the stages. And material is a monolithic structure. Because ultimately you have to get a monolithic structure. You cannot wash with an atom. So that structure, and that structure is digitally designed morphology. Morphology is also digitally designed. I want a little separate. Suppose I want to design a catheter. A catheter which is inserted within the pulmonary veins for the medical applications, if I do that. So, layer by layer manufacturing by particle by particle. Here we are now changing from the layer by layer manufacturing to the particle by particle manufacturing. So this is the thing. This is what I was trying to convey, that this will able to cut between the nano materials for developing nano devices through the extensive application. So this was a thing which I was to convey, and I had to give you the preamble just to convince you that without knowing what you are going to go for digitization, you must know what is that which you are interested in. That is why all those things, nothing is unimportant. Everything is important, but final thing is this. Okay, thank you for your patient hearing. Whether you have heard or not, I do not know. But the issue is that from my end, I say, I presume that you have heard. Okay? Yeah, भाई ये देव ना पानी तो देता ही नहीं.
On behalf of everyone here, I would like to express our heartfelt gratitude to Professor N.K. Banerjee for his exceptionally insightful and inspiring session. Thank you once again, sir, for your presence and for enlightening us with your wisdom. We look forward to more opportunities to learn from you in the future.
End event for the day.
एक्सेस डिनाइड करके आता है एक्सेस डिनाइड तो उस केस में उनको कोड से रिमूव करके